we're covering 3 topics today. And those 3 topics are tariff, surface area, and I'm thinking now, tariff, surface area, and hello, what? Oh yes, Box-and-whisker. Not off to a great start, sorry. Okay, so I'm going to jump right in. We're going to start with tariffs. That forms part of finance. And I am just slightly distracted. My dog has just got back from a little doggy hospital, so she wants to say hello to me. Okay, so we're going to start with tariffs. Now, I know that there's a lot of confusion around tariffs, and so hopefully if we refer to the caps, which is what we always have to do, if we refer to the caps and we see what they have to say, and then we look at how tariffs has always been presented to you through the examining body, then that should set your mind at ease. Okay, so what does CAPS actually have to say about it? CAPS covers the term tariffs quite a few times. The first time we see it is as part of ratio, and we see under ratio specifically rates, and there we see there that it's part of electricity tariffs. So the context is often the most important thing. So after knowing that we deal with it with electricity and tariffs, we still with rates, and we see that it pops up again, but it now says calculate the following types of rates. So this is the first time that we see that we are going to have to calculate with tariffs, and why. The CAPS is full of the in order to. So that tells us why we need to cover those skills, so so that the students are able to, and what is it? Able to make sense of situations involving tariffs. And again, electricity, water, and transport. Nothing new to us. We then see tariffs covered again under patterns and relationships. Now we know that patterns and relationships is very, very broad. But we have always, as a Maths-Lit community, we have really always interpreted that under graphs, rightly so, because that is exactly what it is. But you can't just speak about that. And in order to understand situations involving finance and tariff systems. It's very, very clear that it is here. And so far we've had it under ratio, where we can test it under ratio, rate, and now under finance with graphs. Going one step further, we're still under representations of relationships in tables and equations and all of that. And we see it once again in order to make sense of situations involving finance. It's an exact repetition. So the previous one was just one part of, if I go backwards, you'll see that the previous one was our patterns, and now this is actual representation. So it's the actual graphs. Then working with 2 or more relationships. So now we are thinking that it's 2 graphs on the same set of axes, etc., etc. Again, why? In order to solve financial and other problems, including comparing different tariff systems. And so you will see that the context in which tariffs is spoken about the most in CAPS is financial situations with cell phone, electricity, water. Another example here, still under patterns and relationships, is to find out the tariffs charged for 2 different types of cell phones. It's just an example, that's all. Prepaid versus contract. Again, a possible assessment, and I just wanted to put this in here so that you can see the different ways that tariffs can be tested, and that is to compare the different types of electricity charges and to find the tariffs charged for 3 different systems. So it's not limited to 2 different tariffs. We can be talking about 3 different tariffs as well. I thought that this was quite important to mention here. 2 graphs are drawn to show the monthly cost of electricity on a prepaid system compared to a flat rate. Again, just the context. The fact that the graph representing the flat rate option does not start at 0 on the vertical axis indicates that there is a fixed fee payable every month. Nothing new to us on this option, irrespective of consumption. And then the fact that the graph representing the prepaid option is steeper than the graph for the flat rate indicates that the tariff for electricity consumption on the prepaid is higher. Now, I am going to speak about the step graph because that does come in. You can't cover tariffs without a step graph, but we can also see that we can refer to tariffs with our straight line graphs and you introduce break even in a context of which contract, for example, would be the cheaper one. We also see it now on financial documents. So how have they incorporated under that? In order to understand terminology. And there we can see tariff or charge. So we've got our ratio rate, we've got it under graphs, we've got it under financial documents. And then we actually have this huge piece, which is specifically on tariff systems. And so the tariff systems that they want us to work with, as mentioned in the caps, are the municipal tariffs. And this is, I think, what we all do. We all tend to work with tariffs with electricity and water and sewerage, which now forms part of the municipal bill. And then the old favorite as well is the telephone tariff, but then also transport tariffs, because tariffs is a charge. And so we want to speak about what the charge is for any of those types of things. And then, of course, the tariff or the charge for bank fees. So tariffs, I hope that so far you're able to see that tariffs isn't just that table with the inequalities in it. Tariffs really can be tested in so many other scenarios. Yes, they need to know how to work out the tariffs of water, absolutely. And that is what the students tend to find really, really difficult. And yes, I do believe they need to know the step graph because it is part of tariffs and it comes up again. But the concept of tariffs can be tested in other scenarios. Okay, so we now know all those scenarios. In order to what? In order to calculate costs using given tariffs and or formula, and then to be able to draw and interpret graphs of various tariff systems. This is a biggie here, I think important. Compare in grade 11 and grade 12, you can compare 2 or more different options for a tariff system. And again, why? To determine the most appropriate option. We know that. But also, as part of that same question, we could ask them to perform calculations with the tariff and then to draw graphs with the tariffs. Okay. Then additional comments that I thought was worth highlighting for you. In grade 10, learners are expected to be able to draw and interpret constant, fixed, linear, and inverse proportion graphs. As such, grade 10 learners can only be expected to draw graphs of tariff systems that relate to these types of graphs. And then it says, see later again. In grade 11 and 12, there's no limitation on the types of graphs that learners are expected to be able to draw and also to understand. And then, also worth highlighting, learners are not expected to find break-even scenarios for different tariff systems through algebraic calculations. In other words, they are not expected to use simultaneous equations. But what do we want them to do? We want them to read it off, or here it says they should be able to read off and, if necessary, estimate the values for the graph. And then further on, you'll see that if you do go into the CAPS document for simultaneous equations, it will tell you that they can work with two equations, but through substitution. So those questions where we say show that the break-even point is 5, I know that, and myself included, we always used to say, oh, it's so frustrating. Why are they all using 5 in their answer and then just substituting? But actually, that is what they should be doing, and not the algebraic method of doing that. Does that mean that I don't want my students to know how to do it algebraically? Well, not for me. But I'm hardcore. I still think that there's lots that I feel the students benefit from knowing, even though it's not examinable. And that's what I love about this subject. The more skills you can give them, the better. It doesn't necessarily mean that we have to test them on it. When they do their projects on buying a car or buying a house, there are so many skills in there that are not going to be examined, but they're still gaining so much from that experience. So yeah, I think just remember that. It doesn't limit you to what you can do in the classroom just because something doesn't appear in the CAPS. It does limit the examiners. And when you are setting your trials papers, it's not fair to put something in there that isn't going to be tested in finals. If the break-even point is a decimal, do you go up or down? You would have to go down, because if we take a conventional financial scenario of selling something versus income, and you landed up at 4.5, you have to go up. Sorry, I apologize, you have to go up, because if you only sold 4, you would still be making a loss. You have to go up to the next whole number, even though that will already give you a slight profit. So in answer to your question, do you go up or down? You go up. Okay, we're on break-even analysis, okay? Our topic that we're dealing with is finance, but now specifically under break-even. This section on break-even applies only to grade 11 and 12 learners, and examples of these contexts are basically electricity and telephone tariff systems. Banking. So now we're on banking, still under finance, but tariffs come in to banking when you are comparing charges of different banks and their tariffs. Nearly there. This is, if we take the whole of finance and we look at the cognitive thinking levels, which is in the CAPS document, and we now focus on the cognitive thinking levels associated with financial documents and tariff systems, we see that it basically enters under level 4. Look, there's lots you can do with level 1, 2, and 3, but level 4, our reasoning and reflecting, is when you analyze a newspaper article or something else describing proposed increase in electricity tariffs and make deductions about the implications. So again, it's when you're asking them to form a conclusion based on the tariff and the potential change in the tariff. And so we can see that tariffs really appears in a lot of places in the CAPS document. So it's worth spending the time on, and it's worth making sure that your students understand it. So now we get, there's one more. I thought there was only one, but again, break-even analysis, a level 3 is when you draw 2 or more graphs, and you identify, and there's our electricity tariff. So it's just finding the break-even document. Is this textbook only for CAPS? We follow IAB. No, it's definitely both. If anything, it's probably slightly more biased towards IAB, but it adheres to CAPS completely, and SAGs as well. Okay, so what I did was, actually quite a few people have queried tariffs with me over the past few months. And so I thought, how often is it actually coming up in the exams? And do you know, the first time going backwards that I could find a question as conventional as this with tariffs was 2019. In the IEB final examination in paper 2, and this was the question. These are all in your notes, so you can have a look at them. But this is obviously what we're going to focus on. Now, there was a discussion many years ago at sort of the examining panel level about tariffs and how they are tested. And Umalusi dictated that if we are going to examine tariffs, to avoid the confusion that everybody tends to have, we needed to use inequalities. Because then there was absolutely no confusion about what do you subtract and where does 6 fall in and all of that. Now, I really, really hope I'm going to make your life very simple here. Bottom line, bottom rule. Subtract the two values that are given. It's always going to be the higher value minus the lowest value. We have intentionally kept it simple. This is not supposed to be confusing. And so if I were to work out any of these tariffs, I would go 6 minus 0, and that first one would just be 6. And 10 minus 6, 4 kiloliters at these rates, and 5 kiloliters at these rates, and 5 kiloliters and 10 kiloliters. So yes, inequalities are worth mentioning to your students because they are part of the bill. Sorry, let me just go back one. They are part of the bill. But always, we're just going to go 6 minus 0, 10,5 minus 6. And that's how many kiloliters it would be at the rate. 20 minus 10,5. The second time I could find tariffs was in the supplementary paper from the same year, 2019, but now tariffs appeared in paper 1. 2019 was still the old format of the papers. Yeah, was still the old format. So it could have been in either paper. Then we get to the older system now. And even this older one is an example of what I have in my textbook. The question is just, okay, calculating 24. And you'll see, even without the use of inequalities, it is still 10 minus 6, 15 minus 10. Now, I know, and I'm talking like years ago, I knew that I was confident when it came to tariffs. But somehow when I was teaching it in my classroom, a student would ask me a question that would really just make me think. And then I feel like I was getting confused all over again. And then it would be a disaster of a lesson. And then my poor kids, they would think that tariffs was the hardest thing ever. And I'm like, no, it's not supposed to be so difficult. So I've learned my lesson. Don't overcomplicate it. Keep it as simple as possible. And whatever values are given in your tariff table, simply subtract the greater value, the smaller value from the greater value. And that is exactly this example here. You can see the different kiloliters. The thing I would sort of recommend that you draw the students' attention to are the other charges that are involved. For example, that it would have to be very clear that that is not included or is included. You see, in this case, it does tell you excluding that. So I have worked out the total and then only added the VAT on. And so that's something to draw your students' attention to. And then any other possible admin charges or something like that, that also then needs to be added on after the tariffs have been calculated. If they get to a point, like in this example, 24 falls in that bracket there. So we know that only 4 kiloliters will fall in here, because up until that point we've had 20. So then 4 at the last one. Norma, you asked a question earlier. Does that answer your question about tariffs? Okay, so before we proceed, do you want to elaborate then on your question? I don't know if you want to put your mic on or...
Okay, Norma, I have allowed your mic. You can just open your mic yourself.
Great, thanks. How's it, Tamara?
Hey.
All right, so my queries come through using the old system. You see on your first interval, you've got 0 to 6.
Yes.
Then we've got examples where the next interval starts at 7 and it will go to 10. And then the next interval will start at 11 and go to 15 and 16 to 20. So there have been ones like that. So what happens to that one in between the 6 and the 7? So the ending of your first interval line, it ended at 6.
Yes.
And then your next line starts at 7.
Starts at
There's
7.
a 1 that's missing there. So I've been teaching my kids that if the numbers are not the same, so biggest number minus smallest, as you've said, but as soon as the numbers aren't the same, I've told them to add 1 because it's got to be catered for.
So I'm not sure how awkward this answer is going to be, but Norma, that tariff table that you're working with is wrong. It's just wrong.
Yeah,
so,
but tomorrow it comes up. I pulled it off Twitter, off Swane's website this year already when I set up trials, and so many are set up like that, where it's
really?
500, then the next line starts 501 to 1,000, and then the next line, so it ends at 1,000, the next line starts at 1,000.
At 1,001.
And there are lots like that. Many are like that. So this is why I've raised it.
And so if you were to subtract the smaller from the least, then it doesn't work out, because then if you were to add your number of kiloliters, you don't. I get what you're saying. Gosh.
So this is why you can't, for me, when they give us that, like the Tswane one, in your second line, back number minus front number, you're not going to get the full quantity that's meant in that bracket. It should represent 100 units, but you're only going to get 499 in your second line. And so I don't want to hold everyone up in this forum, but it was something so I disagreed with the way that the memo was worked out in last year's paper for this exact reason.
Yes, because there is no, I know when we have put questions in with tariffs, Lucy have rejected them unless they had the inequalities. So that's super interesting. So I think that Joy says the same thing. You always add 1 unit to the beginning. So would you add the 1 unit to each of the categories?
Yes.
Okay.
And if it was,
Okay.
yeah, so that first level would then be 501. And then after
Yes.
that, everything would be 500. That's how I would say it. But we need some clarity on this at conference, that all of us teach the same way. And
The
I'm
same
worried.
way.
And then in marking, I think because this is so late in the day, as far as timelines go, I think all variables need to be taken into consideration as far as the memo
Yeah.
goes, depending on how we've taught. And
Yes,
not everyone.
I agree with you.
And our sources, our real life sources, are not showing inequalities.
See, and that is the problem. Okay, so I think I think what you are doing, obviously, is correct because 501, let's just say 501 to 600, I think they are counting that as 100 units and not 99.
Yes, I agree with you.
Um,
Because it's from the beginning of the
from
number
beginning.
501
Yes.
to the end
Yes.
of 600.
Yes.
So that's
And
how I've argued it with how I've explained it to my kids.
Yes, that I would do exactly the same thing, Norma.
Okay.
Yeah, that is exactly how I would interpret it as well. But I agree with you, and I think at conference with the examining panel, they would need to form a consensus of using incorrect tables with the wrong notation, because if that's what's out there, then it needs to be accommodating to that.
Yeah, you see, and I would imagine that the municipalities are trying to simplify this because the layperson doesn't know how to use inequalities. So even when there are inequalities, I've still said to my kids, just look at the numbers, back number minus front, inequalities or not, because we can't guarantee the source.
I'm with you. I didn't realize that the municipalities themselves were wrong.
Yeah, so what you classified now on your screen as old style, that's what we're finding from the municipalities.
That's still okay.
And then their second line, where yours now on screen starts at 6, theirs starts at 7.
7.
Yeah.
Okay, well, mathematical literacy wasn't available many years ago. Otherwise, everything would have been wonderful.
Absolutely. Well, that's why we love you for doing it. So thank you so much.
It's a pleasure. But it is worth. I'll also just chat to Karen and Dino and see what they feel, and then they can just maybe talk about it at conference.
That would be amazing. Thanks, Tamara.
It's a pleasure. Okay, so then we get onto tariff graphs, which hit all of us by surprise, quite a few years ago when it made its way into the first exam. Again, rightly so, but some of us had never thought that way. So yeah, it's quite exciting because actually it's quite a real graph to have, and for the kids to be able to understand. Look, the same issue is going to come out with the whole inequalities thing, with a step graph, the open circle, the closed circle. And, it's hard to teach this effectively without getting to, as we call it, and my students call it, too core-ish, that swear word in a lit class, too core-ish. But for me, I would always just take the context into consideration, and then the students would be able to use their logic and see, oh, like 9 a.m. would fall there now, for the participant, and not, okay, let's look at 11. So 9 a.m. at 11 o'clock. So this person, this athletic event at 10 a.m. would be the 11-year-olds. Kind of thing. And I just found that when we focused on the context, it made it easier to understand them. But, you know, kids have been doing crocodile signs since primary school, and it is something that they should be aware of. And there's like a small little disclosure in the mathematical literacy syllabus, for want of a better word, that says that we can expect all grade 10 maths lit students to come with all mathematical knowledge till the end of grade 9. Now, you know, that's one of those laugh in the face of ridiculous notions like that. They probably, some of our students barely passed grade 9, but it is something that we are allowed to test, and it is something that we can assume they know because it's done with them in the first grade 1 to grade 9 kind of thing. So it's not being too core-ish. It is part of maths, and I call them crocodile signs because that just seems to take away the formality as opposed to inequalities. But, you know, I mean, obviously they're both of them. And then we have the drawing of the step graphs. And I love the example of just like a parking tariff because it shows the students visually of a normal parking tariff. And, you know, you always get those, I'm not going to lie, I love them, but you always get those students that are like, what if you parked on the dot, you know, and then they have those kinds of questions. And again, I always say to them, well, what do you think? Do they want your money, or do you think they're trying to give it to you like for free? And they're like, no, they always, you know, they want the highest amount. And so I say, well, exactly. So kind of go with that. And then the last one, so this is an actual tariff table from a bill. This is the water and sanitation. And this, again, is just like Norma and some others were saying in the comments. I think it is important that students know their municipal bill. And so these are the things I would point out to them, particularly a sliding scale. You know, I just think that is such a good word to explain the step and the jump in the tariffs. And, you know, then to go through each one of those, because it just looks like so much happening. And so to break down what those are, I would break it down by saying, okay, let's take each step. How many liters do they talk about in the bill? What is the cost? And then allow them to do the calculation. This particular question was me giving them the total and seeing if they could get to that total. And there's the answer. This is in your notes for you, just so that you can see in some context. And I know that I have answered one of the big questions, well, actually haven't been able to answer, but at least I'm aware of your question. But that brings me to the end of tariffs. Are there any other questions? No other questions. So again, the purpose of this webinar is to give you context to see what the CAP says so that we're all on the same page and we're all following the CAPs, and then at the same time give you some suggestions that you might incorporate into your teaching and some examples that you might be able to use. So if there are no further questions, then we can go on to surface area. So again, let's start. Oh goodness, I say that a lot. You know, when you listen to yourself, if you've ever listened to yourself teaching, you pick up those words that you say all the time that you didn't even know you were saying. Mine is so. Now I'm concentrating not to say it. Surface area. Area is two-dimensional. Surface area is three-dimensional. These are the shapes that we are familiar with. These are shapes that have come up in assessments of all different kinds. I'm not saying you mustn't continue doing your assessments, including all these shapes. I'm just saying that not all of them are examinable. Let us first see how we would solve any kind of surface area question, and we would break it up and either calculate the area of each surface and then add them together, or we would use a formula. I am a big fan of number one, because I try always keep things as simple as possible, in a sense that if I can find a method that works for a lot of things, then I'm going to try and emphasize that method. So when it comes to surface area, if my students understand that it is adding all the surfaces together, it doesn't matter what shape I present them with. They're going to do it the same way. Is it important that they know the formula, that they know how to use the formula? Yes, of course, because not only are they working with particular formula, but then we have the skill of substitution, which comes into it as well. Let's have a look at what CAPS says about this. The first time we see it is right in the beginning of CAPS with grade 11, and it is by way of an example that talks about the surface area of walls and then working it out, and you will see then converting. So first context, painting. We then also see it under conversions. Again, why? Why is it under conversions? In order to express measurement and quantities in units appropriate to the context. And then the quantity of paint needed to paint a wall based on a calculation of surface area. And then this becomes important, in liters rather than millimeters squared. So, let me just have a sip. So we know this notion exists. There are so many different contexts that we could test surface area in. But let us also never lose sight of the fact that we want them to be able to convert the surface that they have worked with as well. It's also under calculating perimeter area and volume, where, well, to calculate perimeter and area, including surface area, and then direct measurements with surface area calculating for each of the following: rectangles, triangles, and circles. For the circles, it can be quarters, semi, and 3/4 using known formula, and then also rectangular prisms and cylinders using known formula. Those are the shapes that we should be working with. Those are the shapes that are examinable. I'm going to explore those shapes and what that means for us. Calculation for objects that can be decomposed into those shapes listed above. That point over there is a saving grace almost, because there are lots of shapes that you can break down into squares, circles, and triangles and rectangles, which is covered. So we can work with them, we can test them, because it is in CAPS. Here, important, these are the formula that are given. So yes, we aren't dealing with circumference and area, but it's worth taking this opportunity to show you the formulas that are given. circumference, the two that we work with, pi d or 2 pi r, area of a rectangle, area of a triangle, and area of a circle. For surface area, only two shapes, only the formula for two shapes are given. Surface area of a rectangular box and surface area of a cylinder. Those are the only two formula that CAPS says they're expected to know. And for volume is volume of a rectangular box and volume of a cylinder. All formula for calculations involving perimeter, area, surface area, and volume will be provided in assessments. Note that in all formula, learners are expected to work with the approximate value of pi 3,14. And we do make allowances for our scientific calculator, of course, because our students have it and it's a skill to learn how to use it. But this point over here, again, I'm that hardcore teacher. I know in finals we must give them the formula, but I still want my students to know it. They're three formulas. They are basic formulas. And my personal opinion is that you need to be able to go through life knowing that to work out the area of a rectangle, it's length times breadth. And so possibly at a grade 10 or 11 level, I'll say to my students, you know, in this test, I'm not giving you the formula. But then by matric, well, quite frankly, if they haven't learned the formula by matric, then they're not going to. Because again, this is something that they have been doing since primary school. So let them then in matric give them the formula because we can, because we must. I was asking my maths lit students one day when we were having a discussion about the formula, and they were saying, you know, ma'am, is it going to be, are you going to give it to us? And I'm like, you know, I don't like to do it. And they really did open my eyes to their perspective. And they said, yes, it's not many formulas for you, but in the grand scheme of things, they have so many subjects and they have so many formulas in different subjects that for them, it just becomes one of so many. And I think that's when I got a bit of grace and compassion towards the formulae and started to be more willing to give it. Again, I will encourage them in sort of grade 10 to learn it, but we do live in a world where anything that they wanted to know is at their fingertips, quite literally at their fingertips. And so there isn't actually a reason for them to know these formula off by heart, because if they did want to work out something, they would just pull it up on their phones and be able to do it. And I mean, nowadays, some of the apps are so fancy, you can like point your camera at it and it works everything out. So, you know, I think it's totally up to you. You know your students and you know your classroom environment. No, learners will not be penalized if they use the pi button on the calculator, not at all. All memos have always accommodated for both. The reason why this says this in the caps is because anything that we do with our students needs to be able to be completed on a pocket calculator, just a basic calculator, which doesn't have all the fancy functions. And so that is why we also stopped using, one of the reasons we also stopped using the compound interest formula is because we would go to any power, but you can't do that on a pocket calculator. So the final exams, both IB and government papers, any student with a pocket calculator should be able to complete that exam. Otherwise, it doesn't comply with the basic requirements of maths literacy. Oh, that was supposed to emphasize already previously. Okay, so possible assessments, integrating our surface area and that is which container requires more material. So those wonderful questions where we test surface area by, say, you know, how much wrapping paper do we need? If I want to put a label on this, what's the maximum size of the label and stuff like that, it's all great because we're still working with surface area and we are still adhering to all of the points mentioned in the CAPS document. So let's go back to these shapes. I have personally tested all of these shapes in my Maths Lit classes. So it is with humble pie, sort of, that I realized that I didn't need to. However, when I'm working with the sphere or the cone, I'm also testing, and I give them the formula. Obviously, I give them the formula. But I am using, then I'm testing the skill of substitution. And that is still a skill that they need to know. Just FYI, the word sphere and the word cone does not appear in the CAPS document even once. I'll just leave it there. Okay, so cuboid, can we quite easily work and test it? Yes. In a cube, yes, same thing. Cylinder, we're all happy about that. The sphere, not so much. The pyramid, I've sort of given it a half a smile because we are allowed to work with shapes, break them up into different shapes that we know. And so the pyramid is triangles. So that's sort of a half. And then the cone, not so much. Does that mean you can't do it in your class? No, absolutely. You are the king of your castle in your classroom, and you know your students. And you know in what context you're going to work with that. And so go for it. Departmental papers, yes. So they are much stricter. Are they, Sandy, are they then penalized if they do use the pi button? Because to my knowledge, they haven't before, but maybe it has changed. I'm going to go on to the cube. So I'm going to work through those shapes. There we go. Okay, so the cube, we know what the cube is. We know it's a cube because all the measurements are exactly the same. And this is the conventional net for the cube. When I am exploring this, particularly with my grade 10s, then I am emphasizing the length, width, height, and I am making them see that the area of 1 would be A times A, L times B, but we try and use the same variable. And that way they can see that I've got 6 of them. And so the formula then comes about that it is 6a squared, or whatever variable is being used. This I find so interesting. And again, I explore this with my grade 10s because you have the most time in grade 10. I find the 11 and 12 syllabus much heavier. These are all the different nets that still make a cube. And so a fantastic way, and these nets, you can find them on the internet. And a fantastic activity is for the kids to discover whether if they cut that out, it actually forms a cube or not. And I like to also give them a few nets that don't work. And again, there are activities that you can find online. What a beautiful ray of sunshine. It'll pass in about a minute. But this one, they're fascinating because you don't think that they're going to actually form a cube and yet they do. And it's very rare to find that student that can just look at it and realize or figure out in their head whether it forms a cube. This is extremely difficult for students to visualize things like this. So it's nice to explore it with them. The two formulae in black in the frame, those are from the caps. So those are the formula that are given. We know that the area of a square is length times breadth, and then we have our surface area of a rectangular box, which if you wanted to explore this and show them how this formula can just be simplified to like 6a squared, like I said, because it is just 2 of the top and bottom, you know, the sides left and right. But that's totally up to you. Sorry, let me just close this blind. There we go. We then get on to the cuboid or rectangular prism, and I went down a great rabbit hole here because I wanted to know what the difference is, if any, between a cuboid and a rectangular prism, and why it was, and there wasn't a difference. And I knew there wasn't, but I had to prove it to myself. And then why is it called sometimes a cuboid, and why is it called a rectangular prism? And yeah, it's really, there's nothing exciting to know about it. So save yourself some time. It's interchangeable, although I do have a slide for those mad people like me that also like to get lost down that rabbit hole. So we have a cuboid. A cuboid, just like a cube, has length, width, and height. But now, by definition, a cuboid is made up of rectangles. And so that also sent me on, you'll see a slide where I wanted to know, okay, but if it's rectangles, what if you have 2 squares at the front or back? Then does it have something, something different? I will refer to your comments on pi in a second. So a rectangular prism, also known as a cuboid, is a 3-dimensional figure made up of 6 sides. That's overriding characteristic, and all 6 sides are types of prisms, all these different vocabularies, and they are rectangles. Then we have the net of a rectangular prism. Normal. This is the net we are all very, very familiar with. But guess what? There are other nets that you can get. And again, this it just fascinates me. Now, none of these nets that I've got up here, they don't have any overlaps, you know, for where you must put your glue. It's just the net to make the cuboid. And worth exploring with your students if you have the time. But different nets, and there we go to the rectangular prism, aka cuboid, where you have a square and not a rectangle. Yeah, nothing exciting. It's still just called a cuboid or a special kind of cuboid. I was hoping it had some fancy name. You know, no, it doesn't. So we have surface area. We know the formula. It looks way more complicated than what it is. I prefer to get the students to visualize the breaking down of the shapes, but it is still very important to show them that the formula is exactly the same thing. You are still multiplying 2 of, and it's just your dimensions that will change. And so here, for anyone that is interested, a cube, also called a hexahedron. That's a fun lesson. When you start getting students to pronounce all the hedrons, and 100 sides, 200 sides, 12 sides, it's just lots of fun if you want to go down that rabbit hole. A cube is still a prism, and a cube is one of the Platonic solids. We're not getting into that, but there we go. A square prism So boring. A square prism is just a special case of a rectangular prism, but at the end of the day, they're all cuboids. And that's where they all come from. I'm not even going to go into that. Okay, so then we get triangular prism. We've got this followed by the cylinder, which again are the shapes mentioned in CAPS documents. So triangular prism. We've got your regular, your irregular, and then the pink one is a right angle one. And this is always how I start when I'm doing the triangular prism with them. Just draw their attention to the fact that the triangle can be any of the three different types of triangles. And then we've got some basic knowledge coming in, some basic knowledge of triangles. And do they know the difference between a scalene, isosceles, and equilateral? Can they even recognize them? And then your right angle triangle, sorry. So that comes with all of it. Again, I will spend much more time on this in grade 10 than I would in grade 11 and 12. In fact, I wouldn't delve into all of this in grade 12 at all. It becomes more important, them understanding the difference between the height of the triangle and the height of the object, also called the length, because your formulas sometimes, particularly with volume, have both heights. And then I go into how the one is a small h and the other one is a capital H. So we have perpendicular height of the base, and then we have the length of the object. And perhaps for those of you that didn't know, the base, the definition of the base of a shape has to be a shape that occurs twice, and basically your shapes are sort of parallel to each other. And that is why the rectangle can never be the base, which is the biggest thing for students to try and understand. But the triangle is the base in terms of volume, if you work in out area of base times height. Then we have the net. Again, we start with a conventional net. We know it's 3 rectangles and 2 triangles. And we then, let me just move my fancy laser. And then we get all these different kinds of nets. Now, this one was my favorite. The different kinds of triangular prism nets that one can get. When it's about finding the formula, working with the formula, we'll get to, but, one slide first. When we are working with the surface area of the triangular prism, I've already mentioned the 3 different types of triangles. It might be that they have to do Pythagoras to be able to find the height of the triangle. Whether, and this has been something that's been raised at conference a few times, whether it's examinable or not, Pythagoras is part of the grade 8 and 9 syllabus. And so they do need to know how to do Pythagoras anyway, depending on what kind of triangle it is. So there's a discussion that would need to happen in your classrooms based on that. If you are using the formula, this is kind of what it looks like. And that is why when it comes to the shape, and you'll see I mentioned it on the notes, that when it comes to the shape, I would definitely encourage them to break it down. But if you are feeling really, really daring, I never have, but if you take this side 1, 2, 3, which is that, is just that of the rectangle. If you wanted them to explore this formula, this part is basically length times breadth. This times that. That's why you're adding the 3 sides. And then you've got your base times perpendicular height over there. So again, this formula looks a lot more complicated than what it actually is. This was purely for interest's sake, purely. It is I would never go into these shapes with my students, but I would show it to them. And I would show the formula, not go through it, but just, wow, look at these fancy, complicated looking formulas that we can get, you know, and there are formulas that exist for all of these different shapes. And then I would still encourage them to, you know, if you were to work out the surface area of this and you didn't have the formula, what would you do? How would you break it up? And if you take, for example, the pentagon, you can break up the pentagon into triangles, still try and work with the triangles, and then a bunch of rectangles. So yeah, it would be long, but it is actually doable. And the same thing with a trapezium. You can create your basic shapes from all of the other types of shapes. I wouldn't do it again. I just want to emphasize that. And I certainly don't want you leaving this call, this meet, thinking that you have to go into all of that. Please, please, please don't misunderstand me, purely for interest. We then get on to the cylinder. The cylinder is, I think, the most complicated shape. The triangular prism, I don't find as complicated until they're working with potential volume. But the cylinder, for them to be able to see that it is a rectangle, normally takes a few, I actually take a piece of paper and I unfold it so that the visual is there. So what do we have? We've got a circle and a rectangle, and the nets, there's not many that you can do with this one, but there the net is. I tried to find, I know that I have watched YouTube videos which unravel it beautifully. And I sat to try and look for them, and I couldn't find any. But I would really encourage you, maybe you have more luck than I do, but to actually give them a visual. If you're not able to do it yourself with a piece of paper, then to try and you know, although everybody has a piece of paper at their disposal, but there are some beautiful visuals out there. I just apologize that I couldn't find it. And this one I liked because of the color, because the students can see the different parts to the cylinder and then talk about the radius versus diameter, but the radius and how you need to work out the circumference in order to get the length. How does this compare with the formula? There is the formula given straight from CAPS, the surface area of the cylinder with a closed lid and a base. And we've got our normal formula, which of course, when the word's all written out, look like a lot longer. And again, I use this word often, but more intimidating than the others. Here are 2 YouTube videos that, you know, take it, use it, lose it, but that I just thought were really nice. The second one, this Math Antics, is a website that I often use and show videos to, even with my 8s and 9s. There's just some really, really nice stuff. And the guy explains it really nicely, and the visuals are incredible. So those are just 2. Just to come back to the point of pi, I know that they have been trying to work away from it. So pi is not given on the question paper in the formula. The learner is therefore not substituting. It was mentioned in one of the IB conferences to encourage learners not to use pi in the calculator. Yes, it does create different answers. Okay, so that's very interesting. Pi is not given on the question paper. Gosh, that is interesting. And I think if I just check, yes, that is what I wanted to speak about, emphasize, hopefully have answered some questions that came my way previously about surface area. So again, I ask if any of you have any questions regarding that or scenarios that you have come across that are different. Excellent, we are making great time. We are disagreeing with our department. Will a complicated shape be considered a level 4? So Estelle, it's very hard to answer that question because it depends on what is asked of that complicated shape. The levels have certain characteristics that they adhere to. It's not just about the degree of difficulty at all. Sometimes a level 3 question is far more challenging than a level 4 question. And it just depends on how the question is phrased and what is asked of that complicated shape. So no, if I think of the first thing that comes to mind is a complicated shape like a garden landscape or something, I can, from that diagram, I can ask level 1 questions, level 2. So no, it's not just given that it's a cognitive level 4, thinking level 4. And then we get to box and whisker. So it is all about the context. I sort of wanted to create this like zooming in effect, but this is the closest I came. So first we have to start with the understanding that data handling is a process. It should never be seen in isolation. And I get frustrated, but I totally understand when we teach it in the lower grades. And we just randomly teach the mean and we randomly teach the range because it's not supposed to just be in isolation. Are the students understanding why we even work out the mean? Do they know where it fits in to everything? And so that's why I always encourage teachers to start with the whole data handling process. And that process, basically, if we break it down into 5 steps and you know how you break it down, generally we talk about the types of data and then we need to collect the data. We need to start with a question. We need to have a reason for collecting this data. So if there is a starting point, that must be it. Why am I asking you what your favorite color is? What do I intend doing with it? But if we zero in on the box and whisker, it starts off being under organizing the data. Because when we take this process and we break it down into, let's say, 5 steps, step 3 would be organizing the data. And how can you organize data? What are the different ways that you can organize data? Well, a frequency table, a stem and leaf, and a box and whisker plot. So we use a box and whisker plot to organize data. Not only that, because in order to understand the box and whisker plot, you need to understand quartiles. Well, where does quartiles fit in? Quartiles fits in when you're analyzing the data. It fits in under measures of spread. When we're analyzing the data, we have 2 different analytical tools that we can use. We can use the measures of central tendency, which we all know is mean, median, and mode, or we can use the measures of spread. And the measures of spread are the range, the quartiles, and the percentiles. That's interesting, Leanne. Very, very interesting. And I'm glad about that. And so how does Box-and-whisker fit into this process, this puzzle? It is a way of organizing data that enables you to analyze it really quickly. So you can't separate the one from the other. That's what a Box-and-whisker looks like. if you're new to teaching Maths Lit and you haven't done Box-and-whisker, that's what it looks like. And that's what I just want to explore a tiny bit. Let's go back to the caps. Where does it fit in? Well, we start with it fits in under summarizing data. No big surprises there. I've just told you that. And it's when we summarize data, quartiles and interquartile range values in conjunction with box and whisker diagrams. We then see it continuing on the next page. It says to interpret quartile values, interquartile range values, and box and whisker diagrams in order to make deductions about deductions regarding trends in the data. So a question, a thinking level 4 question would be if you were asking for their opinion on trends or to predict trends. That would be a reasoning and reflecting kind of question. We can also see it under representing data. How do we represent data? Through a box and whisker, right? But what's important is what appears at the end there. Interpretation only. But you'll see a bit later on. It is okay if we get them to sort of draw it and stuff like that, but not on an examinable level to draw from start to finish. The red square here at the bottom of the screen, learners are not expected to draw box and whisker plots. However, they should be able to locate the minimum, the maximum, the median, the quartile values on the plot. So now, if you ask me as a teacher, well, how will I be able to make sure that they know that? Well, for me to know that they really, really understand a box and whisker, I'm going to get my students to draw one. Will I put it in my prelims or trials? No, not to draw one. But will I maybe ask them to fill in missing values? Absolutely. And so they need to be able to locate those values and then interpret the plot and explain what the shape of the plot signifies in terms of the spread of the data values. That's hard. That's very challenging for students. It would actually be easier if they just had to draw it and just give the 5-number summary. You know, that would be the easy part. But actually getting them to understand what it's all about is the real challenge. And often those types of questions automatically fall, as I've said, under cognitive thinking level 4. Why is it emphasizing it after I've already said it? Ay, ay, ay. When we are dealing with box and whisker, we obviously start with the quartiles. I like this little diagram because although it states the obvious, students don't always make that connection, especially when they are working with the box and whisker. They don't make the connection that the quartiles is splitting the data into 25%, 25%, 25%. Well, at least my students didn't make that connection. And I think I've got it a bit later, but it was also, I would even ask this as a question. I would say to them, what percentage of the data is represented by the box? And they definitely wouldn't all get it right because they don't grasp the box and whisker in terms of percentages. They just know it's the lower quartile. Well, what does that actually mean? Because for them to be able to interpret the Box-and-whisker, they kind of have to know, like, really, what does that mean? This comparison between an actual graph and the Box-and-whisker, okay, maybe it's bordering on core-ish, and I would read my class and see whether I could show this to them. It wasn't a given, you know. Sometimes you just have to focus on the box, and this is what each point means. And sometimes you have students that can enable you to just take it that little step further. But if you were to have an absolutely normal distribution, that distribution literally correlates to the box. And I like to, for myself, but also my students, like to show them the link, you know, between the graph versus this plot. And then, of course, we've got our negatively skewed and positively skewed, which Karen loved to chuck in to the IAB exams. Yeah, when your median is different, and then we talk about, you know, skewed to the left or skewed to the right. Again, I liked this because it took the graph and you could actually draw lines down to show how it impacted the box and how one could assume an outlier, which is always nice to talk about the outliers that exist. Normal distribution, positive skew, negative skew, to the left, to the right. At first, I always got confused with me personally. I would get confused how if the median moved to the left, it was a positive skew, and when it moved to the right, it was a negative skew. And so I had to find my own silly ways of remembering it. But then I sort of made this connection that if there's a much bigger spread here, then that means that here there's probably an outlier. And so that's why it shifted that way. And it is a positive skew. But yeah, it's if your students can find a quirky way of remembering it, then great. But according to CAPS, this is knowledge that we should expect them to have. And this was just a nice definition. I thought I would include it here. That talks about when the median's in the middle, when it's closer to the bottom, and when it's closer to the top. This last slide here, why? Why are box plots useful? And for me, this pulls together the two things. They are useful because they can summarize a lot of data. They can summarize it visually, and they enable you to analyze that data very quickly. You know, like a graph gives you a visual representation of the scenario quickly, and a pie chart in different scenarios gives you a quick visual. It's the same with box plots as well. That brings me to the end of Box-and-whisker. It is not my intention, or has been my intention, to tell you how to teach things, but to hopefully give you some insight into, at the very root of it, why why are we doing it? How does it fall into the syllabus? And what are we hoping to achieve by following it? At the same time, maybe some hints and tips and some clarity. I'm really, really sorry that I couldn't give you absolute clarity on those tariffs. And I'm sure that you leave somewhat disappointed, because when you saw it, you probably thought I'm going to have all my questions answered. But I will definitely endeavor to find an answer that everyone can work towards. This subject is evolving. If you think back to 15 years ago, and it keeps evolving, and it will keep evolving. And I think that's a good thing. And because it has evolved, universities and parents and students, and I hope teachers, have seen the benefit in this incredible subject. So, are there any questions? I love that, Estelle. I absolutely love that. I'm going to write that down. The quirkier, the better. It's the way I remember that you multiply in probability, that you multiply when it's an and. It's a long story, but spandex. Spand and the X. Spandex is how we remember that. You've been very quiet out there. I'm hoping that you haven't left and gone for coffee, because that would be unfair. I'd also like some. And any comments or questions? Nothing. We are very, very early. I clearly just speak very fast, or I might really want that cup of coffee. But at the same time, I know teachers, we are busy, busy, busy people. And if you tell me that a little webinar or a conference is going to finish early or did finish early, well, then it's brownie points. So I hope I've scored a few brownie points. Thank you, Joy. Thank you so much. I'll stay on if anybody is too shy to ask on the chat and wants to talk to me afterwards. Otherwise, have an awesome rest of your afternoon doing everything. I love the little emojis coming up. Thank you. And I would love to see some of you in person. But yeah, keep the questions coming and I'll do what I can to answer them.
Thank you, Tamara. Thank you so much, Tamara. Really appreciate the time that you set aside to do this webinar for us. And again, we will share the link to the recording as well as the PowerPoint presentation. We will get the attendance report afterwards, so we will see who attended and your email addresses and so on. So we will definitely make sure that you get the recording. Thank you so much, Tamara.
Awesome. Awesome. No problem. Yeah. Great. I think if they don't have any questions, then they can leave. Yeah.
Okay, then we're done.
Perfect. We are done.
Thanks, everyone. Okay, we'll chat again.
Absolutely.
Thanks, Tamara.
Wandile, you can watch the recording and then you'll have the... Oh, there, Joy. Can you unmute Joy,
Yes.
please?
Do that.
Thank you. Oh, the comments are lovely. Thank you. Joy, you need to press your mic now. And Sibonelo. There's a few. Still muted. Oh dear, Joy is still muted.
Wait a minute, I'm trying here. I'm just seeing why is. Wait a minute.
It's a pleasure. And technology, you either love it or it just drives you
Yeah,
mad.
yeah. Okay, there we go. Just go. Okay, so yeah.
Okay, say hello.
Kelly is open. And Kelly, you just need to unmute yourself as well.
Joy, we'll keep trying. Hey, I'm in a meeting. My dog wants to be part of it.
All right. Okay.
Thank you. Thanks, Dale. It's an absolute pleasure.
Kate, just unmute yourself and you can ask a question.
Hello. Sorry.
Hello, yay.
Hi, Tamara. Thank you. I was just wondering if you've noticed any trends around the schools, and because we've just had our grade 9 subject evening, and you know, what are the students doing? Because I found it really interesting that you said that, you know, that subject is changing and that universities are changing their attitudes towards maths lit. And we also had a man at our subject evening last night saying that you don't need maths score to go any further, which I didn't, well, no one appreciated that, but you know, he was just making sure that the students were improving their aggregate instead of just sort of, you know, improving themselves. So I don't know, it's a bit of a difficult question. So, you know, what do you think the future of lit is? Will it sort of improve its standard maybe at the end of the year with the papers, so that it can have maybe a bit of a better, what would you say? I'm not sure. Because I feel it's, you know, it is quite easy at the end of the year, isn't it?
Okay, there were a lot of questions in there, so hopefully I can get to them all. In terms of where is Maths Lit going? It's here to stay. It's definitely here to stay. The comment from the parent, I'm sure, was not very appreciated. But the reality of students that battle with abstract maths, the reality of them now having so much more open to them is wonderful. And that is what we are glad about. We are glad that the subject is actually, it's got a bit more gravitas now than what it used to. And in terms of universities now acknowledging that if they have matriculated with the Maths Lit, that shouldn't exclude them from university. Yes, it should exclude them from the obvious courses, but there are so many courses now which a student can go and study with maths literacy, with the proviso that they achieve a much higher mark in Maths Lit. So the universities are saying, okay, if you do Maths Lit, you can still study this, but you have to get above 70%. Which, I mean, again, and this is absolutely personal, I think is a very fair thing. So are the papers going to get harder? No, they really aren't. Particular schools, the kids clock A's and B's, but there are still many schools across South Africa where the Maths Lit student is still not passing. And the subject itself, the very nature of it, has to accommodate all kinds of learners. When maths literacy was introduced, and this is a presentation that, gosh, I did many, many years ago, how we still had higher grade and standard grade and lower grade, and then we had students that dropped mathematics altogether. And that percentage was quite high. And so maths literacy was introduced for that cohort. It was never supposed to be, oh, well, let's take the easy way out or get higher points. It was so that all students matriculated with mathematics in some form. And so they looked, when the syllabus was being created, they looked at, where do we need maths in real life? Let's just equip those students with those basic skills so that when they leave school, they at least know how to work out their taxes, how to read a bill, how to do all of that. And so as much as what the subject has evolved in terms of what is taught and how we teach it, it's still the caps. And the purpose of the subject, I don't think, should be lost over the years. Yes, it has become more popular because it's seen as the easier way out. But there are so many students across South Africa that need the subject like it is. So yeah, there was a huge call a few years ago. You see, Joy, that's just what I was thinking. There was actually a huge call where we just thought, lots of us, and not just us in a small group, but like there was this opinion that maths lit should be done by everybody. It should be a compulsory subject, and then you could still choose to do maths because of the benefits of maths lit. So no, I don't believe the papers will get easier. The subject is here to stay, and my trend that I've noticed is that more and more students are taking it because the stigma is getting less and less. Was there anything else that you wanted answered in that?
No, that's I really love the subject as well. I'm totally not against it. I suppose I'm at a very fortunate, a privileged school where, yeah. So I just feel that girls do take the easy route, and I was just wondering, if other schools experience this as well.
Yeah, it is happening. It is happening. So yes.
Yeah, and if there are teachers, because I'm sort of the only sort of teacher there, so my classes are growing, which is becoming very difficult. So I'm sitting with a person who is doing extremely well and doesn't really need to sit in my class with a person who doesn't do well. I've got a huge...
That is normal. That is exactly what's happening all over. Yes, that is definitely not all over again. But it is happening in a lot more schools than what it used to. And the numbers, if I just think of how many scripts we mark and how they've increased, and the ratio of core to lit, it has increased significantly. So, yeah. Estelle, I just want to answer your question before the chats go. If kids use the formula for simple interest and compound interest, will they get 0? If they use the formula incorrectly, then they will get 0. We definitely discourage them from using it. It shouldn't even be taught. But what we do get is the project kids and kids coming across maybe in the end of grade 11 or grade 12 that have learned the formula. It will never be given to them in a paper. So if they use it, it's on they need to use it, and they need to use it correctly or they get 0. If they use it correctly and get the final answer, they still get full marks. Unless, of course, the question says without the use of a formula, but yeah. Joy, that is amazing. Like, that is amazing. Joy, is your mic still not working?
Hi, Tamara. It's working now.
Yay. Okay.
Long time no see. It's been a while.
Long time, yes. Remember, you can see me. I still can't see you, Joy.
Yeah, well, my
I'll just
camera is
picture
off.
you.
My camera can be released. Probably I can just show you my face. It's been a while. Oh, there we go. That's me. Hi.
Yay! Hey, Joy, nice to see you.
Nice to see you too, Tamara. Yeah, so like I was saying, this year, actually it was last year, my executive head called me into a meeting and said, Joy, I want everybody to do maths lit in grade 10. Because last year I had only one student in grade 10 taking maths lit because of obviously people don't want to do the subject. There's this stigma, like you rightfully said. So
Yes.
we discussed the idea of maybe coming up with specific topics in finance particularly. So we do taxes. I put the booklet together. I used your textbook a lot. I acknowledge source, by the way.
Thank you. Thank you.
Yeah, so we do taxes, we do investments, we do, and many other things that are even outside the scope of the curriculum, of the syllabus, the CAPS document, mainly grade 12 stuff. And
Yeah.
the kids have loved it. The first lesson was to look at pay slips, and they didn't even know that pay slip has so much information on it. The time you paid at the till, who helped you, the telephone number, and many other things. And I did ask them in the first lesson, how many of you throw away your pay slip after just buying from the shop? And many of them pop their hands. And a week later, they always told me, sir, we looked at every information on the pay slip. So till slip, I meant to say. So it does make a difference with the kids. They've loved maths lit. Some are saying they're not even going to carry on with core maths. They'll do maths lit. And I think, you know what, when we engage heads in this issue about our subject, slowly we're actually going to make headway in getting kids involved in doing the subject. So I love teaching maths lit. I've completely moved away from physics. I'm back full time in maths lit now. Yeah.
Yay! All maths lit is the lucky one now.
Exactly. Yeah. Anyway, it was nice seeing you. And yeah, I've got your email address on screen. I'll send you an email and we can chat some more.
Perfect. That would be great.
All right.
Thanks,
Thank
Joy.
you so much. Cheers.
Sibonelu, I think All Copy could probably answer that more than I could about the software for the digital copy. Yeah, I use Snaplify with great success, so I'm not sure.
Yes, maybe I can. So basically, our ebooks are available on Snaplify and also Optimi, but it is it's only those two platforms. But if you have a problem with the software or issues downloading or whatever, pop me an email. So my email address is salesmanager@allcopy publishers. I'm just going to write it down here. And we can try and sort out the issue that you have.
Awesome, thanks. Perfect, thanks, Rosal.
Okay. Sibonelo, is there anything else that you want to ask? Your mic is open.
No, thanks, I'm fine. That's all, thank you.
You good? Okay,
yeah.
super.
I think the only problem with my Snaplify is whenever I write on it, I switch on the pen and I write on it, and as soon as I switch off the pen, everything disappears. So it's just a little bit irritating.
I understand.
Whereas on OneNote, if you write something, the learners can see it. Yeah.
Okay, well, please just send me an email and I can make sure that someone from Snaplify can contact you and sort that out for you.
All right, thank you.
It could be a device issue, but it also, but they will definitely be on it to help you sort that out.
Thank you very much.
Pleasure. Nkele, your mic is open if you want to ask something, if you're still there. You just need to unmute yourself.
Okay, can you hear me?
Yes, we can hear you.
Yes, I can hear you. Yes, this is my first year teaching maths lit. It's exciting, but the kids are struggling. A lot of background from grade 8 and 9, they're struggling. But at least we're heading there.
Are you teaching grade 10s?
Yes, grade 10s.
So they always struggle in grade 10.
Mm.
And it's quite normal. It's very usual, because those are the same, generally speaking, the same students that battled with maths. So they are coming with very little foundation, but give it time. For me, I always think it's so weird. Maths Lit is one of the few subjects where their marks go up over 10, 11, and 12, as opposed to other subjects, you know, they do so well in 10 and then goes a little bit down in 11 and even worse in 12. You should see, just persevere, and you should see the students getting better, mostly as their confidence starts increasing and improving. That's the big thing. They have no confidence anymore in themselves or their mathematical ability. So just keep at it, and you'll see. But welcome to the Maths Lit community. It's a fabulous community to be a part of.
No, thank you. And then will you send us the presentation?
Yes.
Okay. All right. Okay, no, thank you.
Pleasure.
Easton, your camera and your mic is open. Just unmute yourself.
Hello, I'm Easton. This is my first time teaching, and I'm teaching grade 11, 12, and 10 Miss Literacy, but I'm qualified maths teacher. But at the school that
Yes.
I'm at now, I'm teaching Miss Literacy. So I've got a problem. I'm struggling to set like good quality Miss Literacy papers, especially with your level 4 questions. Like I constantly make some of my question papers more mathematically, and then I constantly have to take some questions out because it's very maths, and like I'm like a mathematically trained teacher. So I'm struggling with how to set proper maths literacy questions.
It is tricky, and it's quite an adjustment. It really is, especially when you tend to want to make it core-ish. My suggestion would be to get involved in a cluster. Are you with a government school or IB school?
So I'm at a private school, but we're following the KEPS syllabus.
So everybody has to follow the KEPS syllabus. That's for every school. But depending on your cluster, so if the private school is with the IEB, then you can quite easily find out who else is in your cluster. Do you know, Easton, the other groups of teachers teaching Maths Lit in your area?
No, I don't. I'm new to Cape Town as well. I'm covering all over the Eastern Cape, so I don't know anyone this side.
Oh, so are you in the Western Cape?
Yes, I'm in the Western Cape.
Oh, okay, so am I.
Oh.
So, Easton, why don't you email me, and I'll put you in touch with some other teachers from the Western Cape, and then at least you can touch base and get some advice and get some resources from the others. But yeah, even Joyce, there's lots of teachers that will be very willing to reach out and help you. We've all been there, and yeah, you just need to ask, really. So if you email me, I can see what I can do to put you in touch.
Thank you very much. I appreciate it.
Absolute pleasure. Estelle, if there's a demand for it, if teachers want it, then I'm sure we can organize another webinar focusing on packaging, and with packaging also in terms of how many fit in, because it is taught differently in core and lit. So yeah, I'll make a note, and that's a good topic to cover next time. Oh, Kate, that's wonderful. You will. There's so much you can do with it. Yeah, I'm just so passionate about it. So that's wonderful. And again, just what I said, to Easton, reach out. You know, there are lots of other people like me. We are all equally passionate and also very happy to share. Wandile, are there any differences in content expectations in the IB versus NSC? No, because we both have to follow CAPS. The only differentiation that there is between IB and NSC is the assessment. The IB schools have a subject assessment guideline, which they follow, which is perhaps different weightings, different layouts, different things, but CAPS is CAPS, and every school has to follow CAPS. Anything else?
No other hands?
No other hands, no other questions coming through. Wonderful. I think that's it then. I don't know, it's up to you.
Yeah, I think this is it. Thanks, Tamara.
Estelle.
Oh, there's another one, but thank you, Estelle and Tamara. Okay. Pleasure.
And all I have is water. That's so boring. Have a great evening, everybody. Thank you so much. Thanks to all copy. And yeah, we'll do it again sometime. Thanks, Sheila.
Tamara. Thank you, everyone.
Thanks, Rizal. Okay, bye.
Bye. Bye.